Hello students, welcome to the next section, Unit 5 Note Section 7.2. Here I've already done the warm-up again. Feel free to pause right now if you want to, you got to do it, but if you want some time to catch up and get that done, I just didn't want to waste time or video on it. Notice that in the first one, I listed all my pairs of congruent sides. We're not going to focus on angles right now, but we are going to be talking about similar polygons, which have to do with ratios and proportions. So we are going to do similarity ratio. We are not going to do, and you can cross this out, golden ratio or golden rectangle. We can leave those out. All right, what is a similar polygon? Well, notice this new notation, similarity. It's when you take your congruent sign, right, and you get rid of the equality part, that part stands for proportional. So instead of congruence, which is proportionally equal, this is just proportional. So they will not be equal. What they will have is congruent angles. All similar polygons will have congruent angles, but they will also have what we call proportional sides. And this is really the heart of this unit is polygon, triangle and polygon similarity. So I'm going to erase the word proportional because it really that word means similar, but it's talking about an object's proportionality. Okay, so in this first one we have ABCD is similar to EFGH. These are both polygons. So if we take a look at the side, we visually see that these are two different sizes. We also know that it has congruent angles. So angle A is congruent to angle E, angle B is congruent to angle F, angle C is congruent to angle G, and angle D is congruent to angle H. So I'm going to go right now and just fill those in. So A and E, so that's 53 degrees here. B is going to be 127 degrees. Here we are. And because this is a polygon, let's see, we know that, right here, angle E is 53 degrees. So I'm going to answer this question. We know that angle B is 127 degrees. We don't know if this is a parallelogram. If it was a parallelogram, we would know that angle H would be 127, this angle here, and angle D would be 127. We would also know that angle C would be 53 and angle G would be 53. We don't know that right now because we don't know if it's a parallelogram or not. It could just be a rhombus that has, no, it could actually be, it could be a trapezoid where CD is not parallel to AB. We do know those angles. Now we need to talk about its proportional sides. Without even looking at this, I know, looking at the figure, I have AB and EF. So notice that it goes in order, that AB is proportional to EF. So what is AD proportional to? Well, it's going to be proportional to EH. So we just have to match up the letters from one to the other. And then we have another proportional statement, GH and CD. So we have GH is to CD as FG. Notice these two. So the order has to stay the same. So FG, we have to go BC. And that's the answer to a proportional statement. So what we're saying is that the value, GH compared to CG, is the same as the value of FG as it is to BC. And if I make up random numbers, GH might be, I don't know, 8, and CD might be 2, and FG might be 12. That would make BC 3. And again, I'm just making these numbers up, but think about 8 divided by 2 is 4, and 12 divided by 3 is 4. So whatever those values are, we don't know what they are. We don't have any lengths or measurements to determine those values, but we do know that they are the similar parts. And therefore, if we use their value 8, 2, 12, and 3, if it had those values, then it would be proportional. So I'm going to erase those because we don't know if that's truly what the values are. That was just an example, a numeric example. All right, the next one, here we're going to determine if these are similar. The first thing I'm going to do is check and make sure it has angles and it has the right amount of tick marks. I have, it looks like 1 tick mark, looks like 2 tick marks, and it looks like 3 tick marks. So it looks like to me it does have 3 congruent angles. So I'm going to write that. I'm going to write that angle A is congruent to angle F, and angle A, and then so angle B is congruent to angle E, and angle D, I'm sorry, I jumped to the wrong one, ABC, so angle C is congruent to angle D. Notice it does not go ABC, DEF. It goes ABC, FED. So we need to be cautious that when we go to set up our proportion and see if they're similar, that we are going in the right order. So when we check out when we look at this proportionality and we check to see what's going on, we need to take the appropriate values. So look at between 1 and 2 tick marks. We have the number 15. So although it's a side length, I'm looking between the 1 tick mark and the 2 for the angle measures. So between 1 and 2 and 1 and 2, those are the numbers that will match up. Notice between the angle that has 2 and the angle that has 3, the side is 12. So I'm going to look angle that has 2, angle that has 3, the side is 16. And now I'm going to look between the side that has 3 and the side that has 1, and that has 18. The side that has 3 and the side that has 1. Notice it's the last one in both of these, and that's fine. That's supposed to happen. And so when I set up my proportion, I'm going to do the 15, the 12, and the 18. And I'm going to do the 20. See how the circles, the 15 and 20, match? The 12 and the 16, and the 18 and the 24. Notice that up top I did all, this had to do with triangle, these all had to do with triangle ABC. And this one, all at the bottom, was triangle FED. Notice I didn't do DEF, I'm keeping the order the same. Because if these are similar, that's the order I'm going to go in. It's going to go A, B, C, and then it'll go F, E, D. It'll match 1, 2, 3, 1, 2, 3 for the tick marks. Whoops, sorry, I dropped my pencil. All right, let's see. 15 over 20 will simplify to be 3 over 4. 5, 10, 15, 20. 12 over 16 is 4, 8, 12, 16. That simplifies to be 3 over 4. 18 over 24, 6, 12, 18, 24. So if I divide these appropriately and respectively, we get 3/4 equals 3/4 equals 3/4. And what I just proved is that these triangles not only have congruent angles, which I did earlier, but they also have proportional sides. All of their sides match up. And because of this, I'm able to both give a similarity statement and a similarity ratio. So here's the similarity ratio, what you see in purple. So I'm going to write similarity ratio. Similarity ratio is 3 to 4. I can write it that way, or I can write it like this. I tend to use the word 2. I tend to leave the word 2 out of it, so I tend to use one or the other. I tend to use either a colon or a fraction. These are both appropriate ways of answering that question. That's my similarity ratio. And now I just need a triangle similarity statement. So the triangle similarity statement is going to be triangle. Remember, I'm going to go in order 1, 2, 3. So angle A has 1 tick mark, angle B has 2, and angle C has 3. Angle F has 1 tick mark, angle E has 2 tick marks, and angle D has 3. So I'm going to go in that order. Let me clean this up. Oops. So I'm going to say triangle similarity statement. That's triangle ABC is similar. Notice I changed the notation to triangle FED. So to determine a ratio, you just have to do all the proportions and make sure that they all work out exactly the way that they all match up. Your triangle similarity statement, you then have to match up the appropriate, I work with the angles, but you just have to go in the right order. The last thing you're going to need is to know that all 3 angles are congruent in both of them. So the angles have the same openness in its measure, but they do have different both triangles have different side lengths. The other important thing is that you use your similarity statement. You've used congruence for so long that you have to be careful that you're using that to represent that it's similar, that the similarity means 3 congruent angles and then 3 pairs of proportional sides. All right, we're going to go on to the next one. Notice that it wants me to sketch X, Y, Z, and MNP. I can do that. I'm going to sketch a triangle real quick. X, Y, Z. And looks like MNP is larger. So here's X, Y, Z. And then I'm going to do, okay, didn't like that. I'm going to go, oh, X, Y, Z, my apologies. X, Y, Z. I'm going to do M, N, P. X, Y is 12, Y, Z is 14, Z, X is 16. Okay, not drawn to scale. Let's move it around a little bit. Let's do X, Y, Z. So 12, 14, and 16. It looks a little bit better. So then I'll do M and P, and I'll do 18, 21, and 24. I'm gathering all of this right from the reading, from the language that's there. And I'm going to match up the angles because it tells me that they're congruent, which is great. So we already have that the angles are congruent. We just are going to try to determine if the triangles are similar. So let me move that over. So the first thing I'm just going to quickly state that angle X is congruent to angle M. Angle Y is congruent to angle N. And angle Z is congruent to angle P. That's important. That's the first information. Now I'm going to do my similarity statement. I'm going to, it pretty much gave it to me in order, so I'm going to do 12, 12 and 18, 20, I'm sorry, 14 and 21 and 16 and 24. I'm going to try to simplify this and see if it all works. So 12 and 18 can both be divided by 6. 6, 12, 18, 2/3. 14 and 21 both are divisible by 7. 7, 14, 21. And then 8, 16, 24. If you divide the last one by 8. And to me, looks like they are proportional. So, can we conclude that the two triangles are similar? We can. So triangle XYZ is similar to triangle M, MNP because of 3 pairs of congruent angles and 3 pairs of consecutive proportional sides. I use the word consecutive. That just means as you work around in that same order, that follows that they are consecutively proportional. All right. Next one, example 3. We have LMNO and QRST. Take a look at the order. LMNO, QRST. So it goes in the same order. It hasn't been reflected, so that's good. Find the value of X. So in this case, TS, because it's similar, has to be proportional in ratio with 2. And 6 here has to be in ratio with 5. So what I'm going to do, it doesn't really matter how I set it up as long as I keep the order the same. I'm going to do 2, hold on, 2 is to X as 5 is to 6. Notice I did from top left to top right, and then I did from bottom left to bottom right. So I'm going from the smaller to the larger trapezoid, or what appears to be a trapezoid. This is actually just a polygon. I don't have anything to tell me that it's a trapezoid. There's no parallel sides. So I'm just going to say 2 is to X as 5 is to 6 for these polygons. I'm going to find the cross products. So 5X equals 2 times 6, which is 12. And I'm going to divide by 5. So I can leave this as 12 fifths, or I can actually do it in my calculator and get a decimal, or 2.4. So X here is a length of 2.4. Because it's a length, we can write it as 2.4. It's fine. You wouldn't normally leave a length as a fraction, but you can. If it was half a foot, you could leave that as 1/2 feet. That's fine. It just depends on its use. All right, so now it wants us to find SR. Okay, well, let's just use what we already know. We know that, well, here, let's put in a new variable. Let's call it Y. We can call it whatever we want. But I'm going to say that this 3.2 is proportional to Y. So I'm going to say 3.2 is to Y as, now I can use either 2 and X, or I can use 5 and 6. I'd rather use, because X is a decimal, let's just use our 5 and 6 again. 5 and 6 is going to come in handy. I can use it for every single one of these examples. So I'm going to leave 5 here and 6 here. So 3.2 is to Y as 5 is to 6. Again, left to right, left to right. So 5Y equals 3.2 times 6 is 19.2. So divided by 5. And so we're going to get Y is equal to 3.84. Again, we're in a territory where Y is not repeated. It's just a value 3.84. So I can leave that just the way it is. All right, number 55. This was going to be a homework problem, but I figured I would do a couple more examples before setting you off to do your homework. So this lesson, at this point, if you get it, you can go ahead and just start answering the problems and seeing if you match up with what I have. If you still want more practice, I'm going to do a few more problems, okay? You should have enough to get through most of the homework by now. All right, so find the measure of angle C, write a proportion, and solve it to find CP. Look at what they gave us. They gave us a triangle similarity statement. So we know that W and H have to be congruent. So W and H is 80 degrees, so I'm going to fill in that for angle W. Notice that C and N, angle C and N, have to be congruent. I don't know what they are yet, but I can definitely find that. And then we have P and V that are congruent. So P and V, so if P is 38, V is going to be 38 degrees. I just have to do a little bit of algebra first, so I'm going to do 38 plus 80 is 118. I'm going to do 180, take away 118, minus 118, and that's 62. So I have 62 degrees. So in both cases, we have 62 degrees here, and we have 62 degrees here. Because they're congruent, N and C have to be congruent. C and N have to be congruent. So that's the algebra to determine what the angle measure, what the angle measures are for those. So now we can answer this first one. We're going to say the measure of angle C is 62 degrees. That's the answer to the first one. The answer to the second one is write a proportion and solve it to find CP. Well, I am going to put a variable here. I'm going to call the variable X. And I'm going to do X is to 12.8. Notice that X and 12.8 are in between the 38 degree angle and the 62-degree angle. That side is included between both angles, so those are the proportional sides. The only other sides I'm allowed to use are the two that are given in the right spots, which is between the 80-degree and the 38-degree, and the 80-degree and the 38-degree. So I'm going to make sure I go in the right order. I'm going to put 14.5 in the numerator and 11.6 in the denominator because I went from left to right, so I'm going to go from left to right again. So I'm going to do 11.6 times x is 11.6x, and then I'm going to do 12.8 times 14.5 in my calculator. I get 185.6. So divide both sides by 11.6, and we get x equals 16. So I'm going to say the answer to part B is CP equals 14. And those are my two answers for this problem. There was my proportion. There's my work to figure out my angle. And x is, we solved x for 16. All right. Use the figures at the right to for 53 and 54. So in this case, these two figures, they apply to both 53 and 54. What I don't know, I'm going to just do a little algebra and fill in some of this. So I know that 50 plus 100 is 150. And then 180 take away my 150 is 30. So I know that this is 30 degrees. And now I'm going to take a look at the triangle down here. Let's look at our order. A, B, C is similar to PQR. So it looks like the order is exactly the same. So I'm going to put in the missing information that matches. So A matches P, B matches Q, and C matches R. And yeah, so let's see what the question is here. What is the measure of angle Q? Well, I quickly found that. That was 100 degrees. What is the similarity ratio of ABC to PQR? So ABC, we're going to take one of these sides. Because we already know they're similar, we don't need to set up a proportion. But let's just take 14 and divide it by 20. Because that's my ABC is 14. ABC is 14. And PQR is 20. So we're going to divide both by 2. We're going to get 7 over 10. So the ratio is a 7 to 10 ratio. Again, it doesn't use the word proportion. It just says find the similarity ratio. We know that they are similar. That's what it says. So we don't need to set up a proportion. We'll just get 14 over 20. Be careful. It says the ratio of ABC to PQR. That's 7 to 10. If you did it the incorrect way, if you went from the larger to the smaller, you would have gotten the 10.7. So you want to be careful that you're going in the right order. All right, this one, quadrilateral ABC, is similar to quadrilateral JKLM with a similarity ratio of 2 to 3. All right, so this quadrilateral has a 2 and this one has a 3. What I know about a quadrilateral is that it has 4 sides. So I'm going to sketch out JK, ABCD, and JKLM. I'm just going to do any 4-sided figure here. I'm going to take A, B, C, D, and I'm going to paste, let's make it that 2 to 3. Yeah, that'll work. A, B, C, D, and J, K, L, M. And if BC is 8, it wants me to find KL. And then if angle BCD is 38 degrees, it wants me to find angle KLM. I'm going to call it angle Y, so Y degrees. Well, because we know that they're similar, I think the easiest one to answer here is the measure of angle KLM. Well, that's going to be equal to 38 degrees. It has to because they're similar. Notice right from our statement, BCD and KLM are the same angle. The next one is how do we find KL given that BC is 8? Well, it is a 2 to 3 ratio. So if I were to write 8 is to X, I also know that it is 2 to 3. So 2 is to 3 as 8 is to X. I'm going to find my cross products. 2X equals 24. And I'm going to divide both by 2. So X is 12. And there you go. Think about it. 4, 8, 12. So in this part, A KL is equal to 12. It's a little bit larger. If we were to divide it, half of BC is 4. So 2 parts, 4, 4, would make 8. But I want 3 parts, so 4, 4, 4. 4, 8, 12. All right, you want to draw an enlargement of a design that is planned on a 3 by 5 inch card. You plan to draw on an 8.5 inch by 11 inch piece of paper. What are the dimensions of the largest complete enlargement you can draw? There's a lot going on in this one. So you have something that's already a 3 by 5, right? So here's our 3 inches by our 5 inches. And now you want to enlarge it, to draw it on this 8.5 by 11 inch piece of paper. Well, that one looks something like this. 8. I'm going to use a decimal. It might be a little bit easier if I write it as a decimal. What are the dimensions of the largest complete enlargement? Here's what happens. As you start to enlarge this, it's going to take shape where it's going to look like something like this, where part of it won't fit here. So you can only go so wide or so long, and then you're stuck where you are. So we have to go with the most restrictive enlargement that we can. If we go too large, it won't be on the paper. So here's what we're going to do. We're going to ignore this for a second. We're going to call this side X, and we're going to call this side Y. So what we want to do is we want to see how does 3 over 5 compare to, and let's use the X variable first, as X is to 11. So what I'm doing is I'm using X and 11, and next time I try this, I'm going to do 8.5 and Y, because I'm restricting one of the variables to see which one I could possibly enlarge to be to go as large as possible without going over our paper. So here we have 5x equals 33. And so I'm going to do 33 divided by 5. So x equals 6.6. So what I'm allowed to do is when I extend this 5 inches to be 11 total inches, it would extend my 3 inches to be 6.6 inches. That's where that's as far as it would go. So 5 would definitely become the 11. Think about it. Multiply that by 2.2. 5 times 2.2 is 11. So 3 times 2.2 is 6.6. Well, 6.6 by 11 would fit on the paper. It would only be this long, but it would have the whole length of 11 inches. So I think that's what we're going to go with. I think we're going to be stuck with going with that measurement. So let me erase that. Let's try this other method, and we're going to use 3 is to 5, but we want to enlarge, in this case, not the x, not the y, and be stuck with x, but I'm going to go 8.5 now. So 8.5 by y. So see, look at the setups here. I'm using only one of the variables at a time. So 3y equals, and we're going to do 8.5 times 5, and that's 42.5. We're going to divide both by 3, so we get y equals 14.16 repeated. Now, notice that y can never be 14.16. It would be much too large, where x has the ability of being 6.6. So yes, we can go longer than we can wider, assuming that 5 is what I'm calling length. So here, this is definitely our answer. It's going to be 6.6. So what are the dimensions of the largest complete enlargement? The dimensions are 6.6 inches by 11 inches. Again, that is with a scale factor, and I'm going to write that, but that's with a scale factor what is the scale factor? 2.2. I'll leave that out. Dimension 6.6 inches by 11 inches. So again, this one we were restricted by the particular paper that it was going to become from the 3 by 5 inch card. In the next example, it's the opposite. So we want to go with the largest possible value because in this case, we're taking a map that's a 9-inch by 15-inch and reducing the map. So instead of enlarging it and getting stuck and caught by how long this piece of paper can be, the opposite's happening. We're reducing it and we want to stop in the quickest amount of time so we don't over reduce it. So we're gonna look to see what's possible here. So let's do the same thing. I'm going to use these right here because I already have them drawn. I'm just going to change the numbers. So now you're going from this blue figure to this orange figure. So this one is 9 inches by 15. And then this one is 6 inches, 6 inches by 4 inches. I'm going to call this one X, and this one, oh, here, let me change the colors so that now we're going from the orange to the blue. So see the difference, we're going backwards now. So here we have our X and our Y. So I'm going to say X is to 15 as x is to 15 as 6 is to 9. Notice I'm using the x variable and 6 now, so I'm leaving the y out. So we get 9x equals 15 times 6 is 90. So divide both sides by 10, x equals, divide both sides by 9, x equals 10. So in this case, by shrinking it, x, oh, I totally set this up wrong. My apologies. I thought it was 9 and 5. Let's change this all around. Look at that. 15 inches would be on this side, and 9. Sorry if you watched that for a minute and you were freaking out and wanted to correct me. So x is to 9 as 6 is to 15. Much better. This makes much more sense. When I got the number 10, I said that's not possible. So we're gonna clean that up. So 15 times x is 15x. 9 times 6 is 54. So in this case, 54 divided by 15 is 3.6. So here's what happened. We shrunk 15 all the way down to 6. In the meantime, 9 shrunk all the way down to be 3.6. That's not too bad, right? There's only a little bit of a gap here. So this 15 got shrunk down to be 6 total units, and 3.6 is what's being used on the other side, right? So think about 15 divided by divided by 1.5. Give me one sec. 15 divided by 2.5. Yeah, so 15 divided by 2.5 is 6. So 9 divided by 2.5 is 3.6. So that almost fills out entire card. Let's see what the other method will give us. We're going to do this one in purple. So instead of x is to 9, we're going to do now, so x is to 9 as 6 is to 15. We're going to do y, what did I do? X is to 9 as 6 is to 15. So we're going to do 4 is to 9 as y is to 15. Notice I set it up a little differently than above. Above I did 3 is to 5 as 8.5 is to 11, and I replaced one of the variables with an x, and I did the same thing with a y. In this case, I went from the left image to the right image. It's not going to matter if I did 4 is to 6, so I'll do it quick. 4 is to 6 as 4 is to 6, or in this case, x is to 6 as 9 is to 15. We still would have got 15x equals 54. So I know I'm doing it a little bit differently, but that's just another method to solve. So here we have 9y equals 60. So 60 divided by 9, 60 divided by 9 is about 6 2/3. So y equals 6 2/3. The issue with this, it's too large for the page, right? So if I were to shrink 9 down to 4, so 9 divided by 4 and a quarter, 9 divided by, okay, so 9 divided by 2 and a quarter gets me down to 4, but 15 divided by 2 and a quarter gets me down to 6 2/3. It's too large. So we have to go with this x value here, which would let it fit right where it needs to fit on that piece of paper. Whoops. So the dimensions are 3.6 inches by 6 inches. Again, the 6 was maxed out, 3.6 was not. Alrighty. 2 more, and then you're done with your homework. Again, you can fast forward through this, so you can start your homework. You don't need to, if you can do these on your own, you do not need to follow along and listen. Multiple choice. An art class is painting a rectangular mural for a community festival. The students planned a mural with a diagram that is 80 inches long and 16 inches high. The mural is 4 feet high. What is the length of the mural? I think I'm going to convert everything over to inches, figure out the inch value, put it back to feet. So I'm going to say, so 80, so the mural, so the diagram, let me try that again. The diagram is 80 inches long and 16 inches high. And the mural, we have, it is 4 feet high. We don't know how many inches long, but I'm going to convert the 4 feet high over to 4 times 12, which is 48 inches high. Now that everything's in inches, I can set up my proportion and solve. So I'm going to do 80 is to x as 16 is to 48. I'm going to find my cross products. So 16x, 48 times 80 is 3,840. Divide both by 16. So x equals 240 inches. So 240 inches is equivalent to, divided by 12, 20 feet. So the answer here is 20 feet. All right, the last problem. Money from 1861 to 1928, U.S. paper currency measured 7.42 inches by 3.13 inches. The dimensions of the current bill are shown here. 6.14 by 2.61. If none of us were around in 1928, but some of you might know that year as an important year. That's the year leading up to and after the Great Depression. So the U.S. government probably shrunk money or repurposed money in a different way to save money, because the more we're printing, right, the larger the bill is, the more it costs. That was probably just one savings. I don't know why they changed it. Maybe because that all money had lost its value and they changed it up, but it is what it is. So what we're going to do is we're going to compare and see if they are similar rectangles. So the way to determine if they are is to determine if they're proportional. So I'm just going to set up 7.42 is to 6.14 as 3.13 is to 2.61. So I'm doing length is to width as length is to width. Just find your cross products. Let's see what we get for a number here. 6.14 times 3.13, and we get 19.2182. The question is that equivalent to the cross products of these? So they should be equal. 7.42 times 2.61. 19.2182 3662. All right, I don't have an exact value. However, that is a very, 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 very small difference by 0.15 inches. Inches square. Yeah, so I'm gonna say for this one, these rectangles are similar. These rectangles are similar. Here's why. My assumption is that when they shrunk the bill down, they did it proportionally. However, given the textbook rounding and the US government rounding, I think based simply on the rounding aspect that there's no exact perfect cut, but I think that they really did use similar rectangles here to shrink the bill from what it was before 1928 to what it now currently is after 1928. Okay, well, that's my 2 cents. Here's, you can finish the rest of the work, and this will be due next time we meet. All right, I'll see you for the next video.